Hi, welcome to my channel Engineering Math Support. In this video, we are going to see about an inverse Laplace transform problems based on partial fractions. Let's move on to the video. Find the inverse Laplace transform of the following. They will ask the problems only in the form of L inverse. We have to identify it comes under which method. Here, if you check the first problem, L inverse of 1 divided by s plus 1 into s plus 3. We cannot able to apply the standard formulas directly here, but if you divide that denominator into two separate terms, we can easily apply the formula L inverse of 1 by s plus a form. So that is e power minus 80. To do that, we are going to apply the partial fraction here, 1 divided by s plus 1 into s plus 3. We can introduce a constant for each term. Here we can write a divided by s plus 1 plus b divided by s plus 3. Take LCM, 1 divided by s plus 1 into s plus 3 equal to a into, here the LCM is, this entire term is our LCM, we have to multiply it by s plus 3 plus b into, here we have to multiply it by s plus 1. If you cross multiply, okay, otherwise you observe your left hand side and right hand side of the particular term, which term is missing, that you can multiply. If you observe this first term here, this one is missing, so we are multiplied by s plus 3. If you observe the second term here, this s plus 1 is missing in this second term, so we are multiplied by that. So after taken LCM, we have to cancel the denominators. That is 1 equal to a into s plus 3 plus b into s plus 1. Here put s equal to minus 3. Therefore, here a minus 3 plus 3 will become 0. b into, put s equal to minus 3. So we'll get minus 3 plus 1. Therefore, 1 equal to minus 2b, which implies b equal to minus 1 by 2. We have to make the b term 0 by substituting the s value. If you put s equal to minus 1, the term will become 0. So put s equal to minus 1 in that equation. We will get a into minus 1 plus 3 plus b into minus 1 plus 1 is 0. Therefore, 1 equal to 2a, which implies a equal to 1 by 2. L inverse of 1 by s plus 1 into s plus 3 can be written as L inverse of a divided by a value is 1 by 2. 1 by 2 divided by s plus 1 plus L inverse of b value is minus 1 by 2 divided by s plus 3. Now I will take the constant out, that is 1 by 2 into L inverse of 1 by s plus 1 minus 1 by 2 into L inverse of 1 by s plus 3. So finally we conclude that problem as 1 by 2 into L inverse of 1 by s plus a is e power minus 80. Here a value is 1, we will get e power minus t. Here minus 1 by 2 into a value is 3, so we will get e power minus 3t. Therefore, L inverse of 1 divided by s plus 1 into s plus 3 equal to 1 by 2 into e power minus t minus 1 by 2 into e power minus 3t is the required answer. Second problem, L inverse of 3s plus 7 divided by s square minus 2s minus 3. If you observe this term, we cannot able to apply the standard forms. That means we cannot able to apply a formula directly to solve this. So we have to go for factoring the denominator. If we can able to factor, we will go for applying partial fraction. If it is not possible, we have to go with some other method. Now I'm going to factor the denominator. That is, if you multiply that, you should get minus 3, and if you add the term, you should get minus 2 here. Therefore, 1 minus 3s are minus 3. If you add these two terms, you are getting minus 2. 3s plus 7 divided by s square minus 2s minus 3 can be written as 3s plus 7 divided by s plus 1 into s minus 3. Using partial fraction, we can write this 3s plus 7 divided by s plus 1 into s minus 3 as a by s plus 1 plus b by s minus 3. Now I'm going to take LCM. I already told you which one is missing. By the term we can multiply it. Here, if you observe these two terms, this s minus 3 is missing. A into s minus 3 we have multiplied. If you observe the second term, here s minus 3 is available. We need s plus 1 multiplied by s plus 1. So the denominator will getting cancelled after taking LCM. Now I'm going to eliminate either A or B. Now I'm going to eliminate A by putting S equal to plus 3 there. So if you substitute that, you will get 3 into where and all S is there, replace it by 3. So 3 into 3 plus 7 equal to A into 0 plus B into 3 plus 1. Therefore, here 9 plus 7 equal to 4b, which implies b equal to 16 by 4. Therefore, our b value equal to 4. Put s equal to minus 1 to make b value 0. We will get 3 into minus 1 plus 7 equal to a into minus 1 minus 3 plus b into minus 1 plus 1 is 0, which implies minus 3 plus 7 equal to minus 4a. Therefore, a equal to 4 by minus 4, that is a equal to minus 1. L inverse of 3s plus 7 divided by s square minus 2s minus 3 equal to a value is minus 1. Substituting this, we will get L inverse of a value is minus 1 divided by s plus 1. B value is 4. L inverse of 4 by s minus 3. So we know that minus 1 into L inverse of 1 by s plus a is e power minus at. Here a value is 1, we will get minus t. Then I can take the 4 out and remaining term L inverse of 1 by s minus 3. Here it is look like s minus a form. Then your answer is e power at. A value is 3, we will get 3t. That is equal to 4 e power 3t minus e power minus t we can write. Next problem, L inverse of 3s plus 1 divided by s minus 1 into s square plus 1. If you observe the term, you cannot able to apply the standard formulas directly. Using partial fraction, I can write this term as 3s plus 1 divided by s minus 1 into s square plus 1. How to write the partial fractions I have explained in our video. The link I have given in the description. Kindly go through the link to learn how to write the partial fraction. Here if you observe, this is an ordinary term. We can write a divided by s minus 1. If you observe this second term, it is in the form of inner square. If inner square is there, we can write our numerator as bs plus c divided by s square plus 1. Now take LCM. 3s plus 1 equal to, compare the first term as well as the denominator. S minus 1 is available, s square plus 1 is missing. We are going to multiply by the missing term, that is s square plus 1 plus bs plus c into, compare the second term, s square plus 1 is available, s minus 1 is missing, multiply by s minus 1. We can make the second term 0 by substituting s equal to 1. Therefore, put s equal to 1 in this. You get 3 into 1 plus 1 equal to a into 1 square is 1 plus 1 and 0 into anything 0 there. We'll get 3 plus 1 is 4. Here 1 plus 1 is 2, 2a, which implies a equal to 4 by 2. Therefore, a equal to 4 by 2 is 2. We found a value. Now we are going to find b value as well as c value. All the times the substitution is not possible to find the ABC values. So for that, we have to compare the coefficients. So using that concept, to apply the comparison, first I'm going to simplify the terms as 3s plus 1 equal to a into a square plus 1 into a is a, and here plus bs into s is bs square, and then bs into minus 1 is minus bs, and s into c is cs, and minus 1 into c is minus c. Now I am going to compare the coefficients, comparing coefficients of s square first. So here in your left hand side there is no s square, therefore the s square coefficient is 0 in your left side. Right side, here this is a square term and this is also an square term. We'll get a plus b. Now comparing coefficient of s. Now your left side we will have 3 in front of s, so we have written 3. Here your right hand side you will have minus b as well as c, so minus b plus c is the coefficient of s in your right hand side. So finally I am going to compare constant term. Left hand side you will have the constant term as 1, right hand side term you will have the constant as a as well as minus c. We get a minus c. From that first equation we will have b equal to minus a. We already know the value of a, therefore substituting that here we will have b equal to a value is 2, therefore we get minus 2 is the value of b. From this we can write that c equal to b plus 3. This I will take it to your left side, and c equal to b plus 3. We know the value of b, that is minus 2 plus 3, which implies c equal to 1. Now we found all the values. Just we are going to substitute in this term. We will get L inverse of 3s plus 1 divided by s minus 1 into a square plus 1 equal to, the first term is L inverse of a value is 2, 2 by s minus 1. The second term is L inverse of b value is minus 2, so minus 2, c value is 1, so minus 2s plus 1 divided by s square plus 1. Now I'm going to divide this into three terms, that is 2 into L inverse of 1 by s minus 1 minus 2 into L inverse of s by s square plus 1 plus L inverse of 1 by s square plus 1. We can write L inverse of 1 by s minus a is e power at. Here a value is 1, so e power t we will get. For the second term, minus 2 into L inverse of s by s square plus a square format. It is cos at. Here also a value is 1. We will get cos t. Here plus L inverse of 1 divided by, that means a divided by s square plus a square is sin at by a. Here a value is 1. So we'll get simply sin t. Therefore, your L inverse of 3s plus 1 divided by s minus 1 into s square plus 1 equal to 2 into e power t minus 2 cos t plus sin t is the required answer. Next problem, L inverse of 2s plus 1 divided by s minus 1 the whole square into s plus 2 the whole square. Here also we cannot able to apply the standard formulas. We are going to use partial fraction. Using partial fraction, I can write this term 2s plus 1 divided by s minus 1 the whole square into s plus 2 the whole square as, here the whole square form will be there. So we have to introduce a constant for each power. First term is a by s minus 1. The second term is plus b by s minus 1 the whole square. C divided by s plus 2, d by s plus 2 the whole square. Now we are going to take LCM. 2s plus 1 equal to, compare this and this first term and your left hand side denominator. which one is missing, that you can multiply. Here one s minus 1 is missing, as well as this entire s plus 2 the whole square is missing. Therefore I will multiply the numerator by s minus 1 and s plus 2 the whole square plus b into, compare these two denominators, we come to the conclusion that s minus 1 the whole square is available, s plus 2 the whole square is missing, that we have to multiply s plus 2 the whole square. Now c into, compare the c denominator as well as your left hand side denominator, we can observe that one s plus 2 is missing, so I will multiply by s plus 2, as well as 1 s minus 1 the whole square is missing, we are multiplied by the two terms. Now plus d into, if you observe the last term, s plus 2 the whole square is available, s minus 1 the whole square is missing, I will multiply by that s minus 1 the whole square. Now we are going to find a b c d values by substituting s value. First option I will put s equal to 1. Therefore your left hand side is 2 into 1 plus 1 equal to a into 1 minus 1 is 0. Here b into 1 plus 2 the whole square will come. Here c into 1 minus 1 is 0. D into 1 minus 1 is 0. Now 3 equal to 3 square is 9. 9b, which implies b equal to 3 by 9. Therefore b equal to 1 by 3. Similarly we are going to put s equal to minus 2 to make the other terms 0. We will get your left hand side as 2 into minus 2 plus 1 equal to a into minus 2 plus 2 0, b into minus 2 plus 2 0, c into minus 2 plus 2 0, d into minus 2 minus 1 the whole square, that is minus 4 plus 1 in your left hand side, minus 3 the whole square is again plus 9, which implies d equal to minus 3 by 9. Therefore d equal to minus 1 by 3. We found b value and d value. To find the c value as well as a value, I am going to expand this term by applying the a plus b whole square formula here, as well as here also I applied a plus b whole square, here also a plus b whole square, and here also we are applied a plus b whole square formula. Comparing the coefficient of s cube, s into s square we will get s square, s into s square we will get s cube. So for this the coefficient is a, and here if you observe s into s square, that is s cube, here we will have c, so therefore your right hand side will become a plus c. If you compare s square, left hand side there is no s square, so 0. Here we will have 3a s square, so 3a is the coefficient of s square. Similarly, if you observe this term, we will have s square into b. Similarly here 2s square minus 2 s square, so that is 0. Here we will have d into s square, so your coefficient of s square is 3a plus b plus d. Since c value is 0, you won't get the s square there. Next, s coefficients we are going to compare. If you compare like that, your left hand side is 2, your right side is s into 4 4s. Here minus 1 into 4s both are getting cancelled, you won't get a value, and here b into 4s you will get, so s coefficient is 4b. Similarly here you will get plus s minus 4s, you will get minus 3s into c is 3c. Here you will get minus 2d. Now we are going to compare constant. If you compare the constant, your left side is 1, your right side is, if you multiply minus 1 into 4, you will get minus 4, minus 4 into a you will get, so minus 4a first term, 4 into b you will get 4b, and then 2c you will get here 2c, here d into 1d. Now we are going to solve these equations to get the a value as well as c value. If you observe this equation, 3a plus b plus d equal to 0. We know the value of b and d, therefore 3a equal to, will get minus b minus d, which implies 3a equal to minus b value is 1 by 3. You can write 1 by 3 minus of d value is minus 1 by 3. So therefore minus 1 by 3 plus 1 by 3 is 0. So which implies a equal to 0. You can write it here, a equal to 0. So we know the value of a, b, d. We can substitute any one of the equation and we can find c value. If you observe this equation, we need c value now. So 3c, I will take it to your left side and I will take it this to your right side. Here 3c equal to 4b minus 2d minus 2. We know the value of b value is 1 by 3, d value is minus 1 by 3 and minus 2a. Therefore, 3c equal to 4 by 3 minus of minus plus 2 by 3. I will take the LCM as 3, so we'll get minus 6 here. So 6 minus 6 will get 0 there. Therefore, c value is also 0. We get c equal to 0. So using these values in this equation, we'll get our required answer. Substituting these values in this, we will get L inverse of 2s plus 1 divided by s minus 1 the whole square into s plus 2 the whole square equal to a value is 0. So I didn't write that one. Next b value is 1 by 3 divided by s minus 1 the whole square. C value is also 0. I didn't write that one. D value is minus 1 by 3 divided by s plus 2 the whole square. So we can rewrite this as take the constant out and write the term as L inverse of s minus 1 the whole square. Similarly, minus 1 by 3 L inverse of 1 by s plus 2 the whole square. If you observe these terms, it is look like L inverse of f bar of s minus a, that is e power at into f of t form, and another form is L inverse of f bar of s plus a, that is equal to e power minus at into f of t form. This f of t also can be written as e power at into L inverse of f bar of s, and here e power minus at into L inverse of f bar of s. If you apply this, we will get 1 by 3 into, this term can be written as e power at into L inverse of f bar of s. L inverse of, this is f bar of s minus a form. We will make it as s form, that is where and all s minus is there, you put simply s. You get s square. Similarly, here minus 1 by 3 into e power minus at. A value is 2. E power minus 2t into L inverse of 1 divided by, here also where and all s plus a is there, simply put s. So we get s square. Therefore 1 by 3 into e power t. We know that L inverse of 1 by s square is t. Here 1 by 3, here also e power minus 2t. L inverse of 1 by s square is t. So from this we can take the common term as t by 3 out. We can take the common term as t by 3, that is into t by 3 into e power t minus e power minus 2t is the required answer. In the last problem, L inverse of s square divided by s square plus a square into s square plus b square. Here also we can apply partial fraction to solve this. We can write a square into a square plus b square as denominators are in the form of inner square. You can write as plus b divided by s square plus a square, and that second term can be written as cs plus d divided by s square plus b square. So to write the partial fractions, I have given the link in the description just to go through to write the partial fractions here. Now take LCM as the missing term, s square into as plus b into, here if you compare the denominator, the missing term is s square plus b square. If you take the second term, if you compare, the missing term is s square plus a square. Now We are going to extend this and we are going to compare the coefficients. So for that I am going to multiply this a s cube b s square plus a b square s plus b b square. Here c s cube plus d s square plus a square c s plus d a square. If you compare the coefficient of s cube, side there is no s cube, so 0. Right side will get a plus c. Similarly, if you compare the coefficient of s square, we'll get the term left hand side coefficient is 1. Your right hand side is b as well as d. You will get b plus d. Next, compare the coefficient of s. There is no coefficient in your left side, so it is 0. And your right side is ab square is the coefficient of s square. Similarly, here a square c is your coefficient of s in your right side. So finally, if you compare the constants, left side there is no constant 0. Right sides, if you observe, you will get b square and d a square. So if you name these equations as 1, 2, 3 and 4. So now 1 and 3 we can solve, as well as 2 and 4 we can solve. If you observe that 1 and 3, if you see that left hand side is 0, so therefore your a value is 0 as well as c value is 0 you will get. If you solve this equation 2 and 4, I'm going to multiply this equation 2 by a square, which implies the term will become b a square d a square equal to right hand side is a square. If you observe that equation 4, we can write b square d a square equal to 0. Now if you subtract this, you will get these two terms are cancelled. Here b, if I take common, you will get b square minus b square equal to a square. Therefore your capital B equal to a square divided by a square minus b square. If you substitute, you will get our d value, that is d equal to 1 minus b. D equal to 1 minus b value is a square divided by a square minus b square. If you cross multiply, a square minus b square minus a square divided by a square minus b square. A square getting cancelled. So therefore our d value is minus b square divided by a square minus b square. If you substitute these values, L inverse of a square divided by a square plus a square into a square plus b square. A value is 0, so I can substitute the b value. B value is a square divided by a square minus b square whole thing divided by a square plus a square. And here c value is 0, so L inverse of b I can substitute minus b square divided by a square minus b square divided by a square plus b square. So taking constant out, that is a square divided by a square minus b square, and I can write L inverse of 1 divided by a square plus a square. Similarly here minus b square divided by a square minus b square, L inverse of 1 divided by a square plus b square. Now if you apply the formula, we will get the term as a square divided by a square minus b square into, if you observe this, it is look like L inverse of 1 by a square plus a square, that is sine at by a, here a value is a only, minus b square divided by a square minus b square into, it is nothing but sine bt by b. Here we can cancel an a and here we can cancel a b. Here the common term is 1 by a square minus b square. Remaining term I can write it as sine at minus b. Sine bt is the required answer. If you want, you can remember it as a result also. So why I told to take this as a result means, in your problems sometimes they may ask like this: s divided by s square plus 4 into s square plus 16. and we will get a value is 2 here, b value is 4. We get a square minus b square a sin at minus b sin bt. Easily we can remember the answers if you know this as a result. 4t divided by minus 12. If you want, take common terms and cancel. Similarly, L inverse of, they may ask sometimes, a square plus 1, a square plus 9. So here a square is 1, b square is 9. So 1 minus 1 by 1 minus 9 into a into sine at. B value is 3, 3 into sine 3t. So we can write our result as sine t minus 3 sine 3t by minus 8. I hope you will understand the concept. Try to solve more problems in the method to understand the concept very well. Kindly subscribe and press the bell icon for further notification. Thank you.